Hello and welcome to the stream. My name is Dow Codes, or Daniel Olvera, as always. And today we're going to be doing a little bit of something a little different. It's something we're going to be implementing for the next little bit. So every Tuesday, we're going to be doing a system design interview practice question, just to get in the mindset of software engineering and be able to talk through some of the nuances. This is both for my benefit of I want to get better at these kinds of things and be able to identify different aspects of a system and then talk through them at a high level and then dive into details as needed. But then also just a nice way for us to kind of have a conversation about what software architecture in the enterprise world looks like. Because that really is one of the core reasons that I want to do this, is to help people understand that gap of, okay, I know how to code a for loop. What does that mean for enterprise app? And then just in the other kind of side of the business, on Thursdays, we're going to be doing, so at the beginning, the first 30 minutes is going to be, so the first 30 minutes of Tuesdays are going to be the design prep questions. And then we'll get into actual coding, just live coding. And then on Thursdays, the first 30 minutes is going to be a design pattern. So if people don't know what the Gang of Four is, we could first get into that, but we'll take a design pattern and break it down and either add it to Breakpoint AI as an example, or if not applicable at the current time, make a sort of sample app to show a real life thing. So not just, animal for a dog and an animal to show a hierarchy, but what it actually looked like in real life coding. So today we're going to get started with a system design question. And we'll go pretty high level the first time we do it, and then we'll revisit this, and it's kind of a living document. I'll probably make a repository for these things, and it's going to be mainly generated in Markdown. So let me actually create a new window. So for the first one we're doing today, we are going to do Twitter. So in college, actually, that was one of my junior year projects, was doing a Twitter clone. And so a lot of the basic aspects I've actually implemented in software myself, which was actually a really cool project. And something like that is kind of the reason I really liked my program that I did, because we got to kind of implement a lot of the features that would be required for an enterprise software architecture. So, okay. So in the standard way you're doing system design is by having, you first get the functional requirements out of the way. So like what actually is required from this system. So let's just do Twitter system design. We're gonna pull this up in a Markdown, and then we'll do some diagramming as well. So we'll throw that in a different way, and I'll probably do Paint and then throw that in there in a nice and easy way, just like a screenshot or whatever. But so Twitter system design. So the functional requirements first is from a user's perspective, right? So the things that Twitter can do, and the things that we'll focus on here, is view posts in a feed. And posts are text with optional image. You can like, comment, retweet. I don't use Twitter or X, so I don't really know what you could actually do. You favorite, save it. You could save/favorite it. That's probably fine for now. And then 3, you can upload a post. And then what else can you really do in Twitter? You could search for posts, search trending by topic or generally. Anything else from a Twitter perspective that we'd want to implement? So we can view posts in a feed. We can like, comment, retweet, save, favorite it, upload a post, search trending by topic or just generally. What else can you really do on Twitter? You can get notified about someone posting. You could follow people. And your posts in a feed are a mix of algorithmic recommendations and then from followed, right? So you want to see your follower, or your followers want to see your posts, and when you follow someone, you want to see their posts, right? So these are the functional requirements that we are going to do. So, well, users, it's a pretty well trodden path, right? How do you sign up with the user? We don't need to do that, right? That's generally what they're going for. That what they're going for is, are you able to break down this list of items and actually understand, oh, okay, with this, I need XYZ, right? With posts in a feed, I need to be able to have an algorithm to get my next page of posts, right? Because you're not just saying, give me all the posts in the world. You need to have a nice queue way of doing this thing. So when you refresh, it's quick, right? So from a functional requirements, these are the things it's going to do. Now, how it's going to do them, things like, I'm trying to think of the best word to describe this. So not functional requirements, but more of development requirements. So this is going to be a highly available application. Highly. This is going to be able to handle millions of users, both uploading posts and viewing posts, viewing their feed. What else? In seconds, be able to notify all followers about a user's new post, right? Because when you refresh the feed, if someone posted, you want to see it, right? You're not waiting 15 minutes. There's no data delay. You can't have like a data sync that is asynchronous that says, oh, well, I'll pick up that post later. It needs to be pretty quick, right? And then you need to be able to see the images and all these things and where they host them. So lots of things in that kind of realm that requires you to do this. So from a super simple standpoint, we can now break them into API endpoints. So this is, we're going to assume you could be a native app or a desktop, doesn't really matter, right? We just have a client agnostic API. Typically in these sort of system designs, the backend is where the interesting magic happens. Like a front end, yeah, you should be paging things. You should do lazy loading of different things. You should do caching, but like, right, a lot of user applications are very similar in that kind of way, where it's you're not reinventing the wheel when you do a new social media app, right? That's not really what we're going for. So we're just gonna skip to the back end, because once you hit the API, then you kind of have the interesting bits of architecture. But yeah, let's start. Let's just go API endpoints. So the most basic set you're gonna have is a upload post endpoint. Going to have a get recommended feed page endpoint. So this is by user. So when a user logs in, they want their recommended posts. They need to have some sort of get trending feed endpoint. And this is more like get trending endpoint, get feed endpoint. These are both paged. Get page of posts for feed. Get page of posts for trending endpoint. Let's see, what other endpoints do we really need to do? I mean, you need to be able to follow people, follow user. I mean, the whole CRUD operations on a user. So unfollow user, follow user, and then you need to be able to edit your user, add your user, delete your user, etc. But we'll just group those into maintenance ones. It's not really important if you do that. So yeah, let's keep going. So the first thing we're gonna have to realize is that posts aren't going to be able to directly save into a database, because the problem with that is an API can't handle the concurrent requests that are going to be required. The scalability of this API is, how do you handle an image if you just post it directly to? So a better way to do that is to save it off to a blob and then handle the getting of the blob later on. And I'm going to be just full transparency here. W3 School does a really good job of doing these kind of things. I want to say they did a Twitter one specifically. Twitter system design. Yeah, so W3 School does a really great job, but really we're just going through this together. But that's kind of the big thing I wanted to show you guys, is just they have really great things. And look at that, functional requirements, and they call them non-functional requirements. So highly read heavy, didn't really do that. So high availability for the tweet engagement, right? So that's the thing we were saying earlier. So yeah, I just wanted to notate that they do really great work. And I think it's just really, really worth for you guys to go through them if you're looking for a job, or even just like being able to talk about these kind of things. It's really, really interesting. So yeah, just wanted to point that out while we're here. So we can go back and we'll continue down this road. Okay. So follow and unfollow user. And there we go. Okay. So the way, let's do some implementation now, right? So let's get a little more granular on the upload post. So there are a couple limits that need to be put in place here, right? So if it's a video, so post content, max of, what is it, 256 characters? Let's say 500 characters for our, I don't actually know what Twitter puts a limit of. Max of 500 characters for text. You can tag users. You can do hashtags to bucket the content. And that's another thing you can actually do, is functional requirements have, that's search trending by topic. So the topic is hashtags. Boop, boop, boop. Okay, or just generate. Okay, do hashtags to bucket the content. What is a max of one image? I don't actually know what this is, if this is true or not, but max of one image in post, or one 15-second video. That makes sense to me. What else? So post content, maybe per user, max of 1,000 posts a day. Per user, max of 1,000 posts a day. So really that's a artificial, how many people are actually posting that much, but just in terms of throttling, those are the kinds of things that you need to think about, is if you are trying to handle certain requirements of a post is able to be uploaded in a certain amount, 1 million users times 1,000 posts, that's a lot of posts per day that are allowed. So we have an API that receives this endpoint, and we could really think about this as a microservice. And actually, let me pull up Twitter. Okay, so you could really think about it as microservices, right? Because you want to have multiple different scalability options, because your upload posts aren't going to be the same endpoint as your get feed, right? Your get feed, everybody's doing that, and generally not everyone is making posts on Twitter. Many people are just reads. So like W3 Schools was saying, Twitter is a read heavy system, so we can keep that in mind when we talk about scalability. And we're going to keep this simple. I'm not going to go into true UML. I find that early on when you're iterating pretty fast, I don't like UML because I'm bad at it. Okay, but we're gonna call this the upload post. And I'm going to talk in Azure land, but we could, this could be Lambdas for AWS as well. But this is basically a serverless function. So where it has its own compute space and has its, it kind of manages its scalability. These could also be containers, right? Where it's, if you have a pod of containers that are able to scale and, horizontally and vertically, you can do the same thing. But for our purposes right now, we can start with high level of just like, this is serverless compute. However you do it, just allow it to be in its own space off in the corner, for separation concerns kind of reasons. But so you have an upload post function, and this directly is going to be talking to a backing store of blob storage, because the best way to handle things like images, videos, is blob storage. So, and it's really going to be talking to two things, because while it's good to handle blob storage with discrete things like videos and the other things, we actually have other things attached to our posts. So like the content, the text and the tags, and we're going to want that in a structured database. In a simple world, this could be SQL, could also be in NoSQL, but this would allow you to have cross-references to users so that when you tag someone, it's a real user and you can connect it with user identity and just a foreign key, which makes it super simple. So I'm going to do a relational database of some sort. SQL's the one that comes to mind here, and that's the one I've implemented before, but could be anything. So in this structure of a post, we'll actually go with this one. We can call this a post. This is going to be an ID, just for uniqueness concerns, which could be a UUID. Then you have like does Twitter have post names? I don't think they do, but post content, just a string. We'll make this a little bigger. Then you would have things like the optional video or resource link, which is going to be a fully qualified link to the blob storage. So then in S3 or Azure Blob Storage, you're directly pointing to the resource so that when you rehydrate this post for a user, it's really easy for the front end to then collapse these things down. So this is going to be a URL. And then you might have a series of tags, which is going to be in a database, we're going to pop this out to a many-to-many table. But for now, we'll just do trying to think of the word. We'll drop it to a different table of just a relational table that will connect you with users or tags is going to be content. So it's going to be like hashtags. So then you could have some sort of aggregate that would allow you to in time get what's a trending post. And I think we're going to need to put some more thought into that, because that's not the way we're going to do it. But I think for tonight, we'll probably keep iterating on this. But the basic thing is we're just going to have a tags for now. Some sort of aggregate trending is going to be a later function. So maybe a many-to-many with IDs. And then let's see, what else do you need? You need tags. Well, tags is like a user. Do you add a user or do you tag a user? Hashtags as well. What else is into a max of an image per user, and then a user ID, which is a UUID for it. And that's really it, right? So you've uploaded a post to a user, but now how do you actually exercise that out to a follower, right? Because there's a big difference between, okay, now I have a thing in the database versus, okay, but I need to now go alert all these followers about this thing. We had a queue that actually you would pop for each item in the queue for each post, this would then go off to a separate, let's see, what's a good queue shape? This is a post queue that then would allow you to, for each post, once uploaded to the relational database, be sent to the queue, and then it would be able to churn on the posts. So instead of having, oh, I have the front end keep polling and polling, it's actually a push model where I get a queue that takes my posts, finds the relevant followers that need this post, and I push it out to them, right? So in the land of, right, the reason we do queues and things like Azure Service Bus queues or Azure Service Bus topics or whatever, you could have subscribers. And that's probably the way I would implement it, is with a topic and subscribers. So then for each follower, you would have a subscriber. But you could also do queues and do it as a serverless function. Then you'd have a process queue for each thing. That's another Lambda. So then you would have another asynchronous thing. And we'll go with that for now. So a post queue and then a little function that pulls from, that gets populated for each post, that then is a process post function. And this sends the post to the followers of that user. And this function scales huge, right? It only takes a couple seconds because you're just accessing, obviously in the case where you have millions of followers, right? If you're the most active or the most popular account on Twitter, then it takes a little bit longer. But your notify user becomes a asynchronous function that gets fired off in a fan sort of way, right? So the single post from the popular user takes the same amount of time as the one follower guy over here, but then the notify users fans out, right? So yeah, this is, I think I'm going to stop here. I want to keep them bite-sized and short, just to be able to talk at a high level of what's actually going on with software. But I think, just starting off, the upload post, it's more than just taking a post and then sending it to a database and then coming back, right? There's a lot of things that, if you have 1 million users, scalability and availability becomes really powerful things and really important things. It's almost top of mind at all times.